Okay, happy Funky Friday, Year 11. Great to see you guys that have joined me. Today is, I suppose, something that you need to sort of be here for and to participate in. Now, you should be at every lesson, okay? There's no excuse other than being sick if you're not here. I do record these so that you can go back and re-listen to what I've said, but it's important that you participate in the lessons, the timetabled lessons, and I've been taking attendance by the participation in the Kahoots and those sorts of things. So what I've actually added, let me share my screen with you people. This is our checklist for this week. These are the final activities, and you'll notice that we've got join Friday's class or watch the video, played Power Rule Kahoot. So that's going to be the first thing that we do today, just to do a reviser on what we've already done. Now, if you're watching this after class is finished, then you cannot have said that you've played the Kahoot. For those that are here right now and that participate in the Kahoot, once we've done that, you can put done in there. And then I'll give the discussion about turning points, which is what we're looking at today, and then leave you guys to it. But it's important that you are here during class time to get the most out of this. And then also to make the most of me sitting here ready to field questions from you to support you in this journey, okay? All right, now I've had a few problems with Kahoot. So this morning it's been a bit slow. I don't know if it's high traffic because there's so much online learning going down, but let's just give this a go. Okay, so we're going to look at the power rule and derivatives. Fingers crossed this works. Come on. Let's see if it, oh, looks like it's working. There we go. I'll get you guys to join for me. There we go. All right. I'll give you 2 minutes to join. 2 minutes to join. Wangdui, TT, Julie, Tree. Good to see you people. Dat, Mindat, Chloe. Lovely to see you, Chloe, Taichi, Sue, HP. Fantastic. Still a minute and a half to go to join. If you already joined, grab yourself, like I said, a cup of tea or a water. Zhang, Sue, Fung, Yi Hyun. Excellent. One minute 15 to go. If your friends aren't online, maybe text them and say, come on guys, get online. Nick, Mike, good to see you guys. Funky, fresh Fridays, getting ready for the weekend. All right, that's what it's all about. 15 players so far. 50 seconds to go. 50 seconds to join. $30 seconds and we'll get started. Min, welcome, just in time. $15 seconds. 5, 4, 3, 2, 1. All right, let's do this. One out of 15. What is the derivative of 9x? Derivative of 9x. And the correct answer is 9. Julie starting up as in the lead, followed by Nick. Question 2, what is the derivative of 4x squared? The derivative of 4x squared. 4x squared. What do I do? Multiply the exponent by the coefficient and add a y minus a u. What do I do? Eight x, that's right. We take the exponent here, we multiply the coefficient to give us 8, so 8x, and then we minus 1 from the exponent here, so that's 8x to the power of 1, but we don't show the 1, we just write 8x. Julie still in the lead. Nick still in second place. What is the derivative of 7x? Oh, this is a hard one. Is it really though? And of course the answer is 7. What is the derivative of sin x? Now I don't expect you to know this one, so this is going to be a guess for you. The derivative of sin x. Now the derivative of sin x and cosine x are always the same, and you won't come across that in the IGCSE, but I just quickly did this. But the derivative of sin x is cos x, and the derivative of cos x is actually minus sin x. Okay. Micah in the lead, and Mindat coming second. What is the derivative of x to the power of 5? I think I'm only going to give 10 seconds for these, okay? I'm going to give 10 seconds for these. So the derivative of x to the power of 5, I think that's enough time. 5, 4, 3, 2, 1. Any movement there? Yes. Oh, we've got 2 girls in the lead, Micah and Julie. Okay, well done, ladies. Show those boys how it's done. Nick's still in third place, hanging around, as well as Fung and Yi Hyun. What is the derivative of 2x to the power of negative 3? 2x to the power of negative 3. What does that all mean? We take the exponent, we multiply the coefficient of x. Our coefficient happens to be 2, so we're going to multiply minus 3 times 2 will be minus 6x, and then we take 1 away from the exponent. So minus 3 minus 1 is minus 4. Oh, Micah lost the top spot. Julie's there, closely again followed by Nick. All right, what is the derivative of cos x? Now, I just told you that before. What is the derivative of cos x? Now, the derivative of sin x is cos x. But what's the derivative of cos x? Minus sin x. I said that before. And we have 7 people that remembered or just guessed. But don't worry, you won't need to know that for the IGCSE exam. Nick, taking the lead for the boys. What is the derivative of x squared plus 7? The derivative of x squared plus 7. Is that 7 times x squared minus the 2, carry the 3? (2x), that's right. We take the coefficient, of the, we take the exponent, we multiply that by the coefficient of x, which gives us 2x, 2 minus 1 is 1, and then the derivative of any constant is going to be 0. Anderson joining the top 5. What is the derivative of 4x plus 3x to the power of 3?
4x cộng 9x mũ 2.
Four plus 9x squared. Well done to those 13. Change there.
Boy, turn off your mic.
Up in third place. Look out, Fung and Nix. He's coming up. Okay, girls. Let's step it up a notch. Show these boys where it's at. Okay, 10 out of 15. What is the derivative of x? What is the derivative of x? One, excellent. As we take the exponent, what's the exponent of x? Well, we know that's 1. What's the coefficient of x? It's still 1. So 1 times 1 is going to be 1. All right. And then x to the power of 1 minus 1, that's going to be x to the power of 0. Anything to the power of 0 is 1. 1 times 1 is 1. TT joining the leaderboard. Welcome, TT. 2 girls there, Julie and TT. What is the derivative of negative x? Negative 1. Oh. What is the derivative of 4x minus 21? What is that? One, 0, boom. 4. Okay, TT, back on the scoreboard. Welcome back, TT. 13 out of 15. What is the derivative of 4x minus 30? Another hard question. Super hard, this one. Maybe I'm being sarcastic. No, Mr. Luke wouldn't be sarcastic. Four, 3, 2, and 1. Should be 4, shouldn't it? There we go. Oh! Someone went for 4. What did they go for? 2x. How'd you get 2x? Interesting. No movement on the leaderboard. 14 out of 15. 2 to go. What is the derivative of 5x to the power of negative 3? It would be the green one, wouldn't it? Yep. No movement there. And finally, last question. Who's going to take it out? What is the derivative of negative 3 cos x? Oh, snap. Positive sign. Okay, so if we have negative 3 cos x, now we know that the derivative of cos x is negative sine. So negative times a negative is going to give us a positive. So we end up with positive 3 sine x. Excellent, we had 12 people get that correct. I'm very impressed. Well done, guys. Pat yourself on the back. Now, who are the winners of today? Anderson in 3rd place. Well done, Anderson. Where's the music? Fung in 2nd place. And Nick coming in 1st place. Just bask in the glory, guys. And Julie and TT, there you go, runners up. Bask in the glory for a little bit. There you go. Take that in. And let's get into it. Okay. I'll just leave that running there. Cancel. We'll leave that there for now. And let's just get into today's lesson. Okay, turning points, exciting times. All right. Okay, turning points. Now here we have a graph. Where's my, let's go, I'm gonna have to use something colorful here. Let me use green flavor. Actually, let's try something that we don't normally use. Let's use this, what's that, orange? Try orange. That works, okay. So here we have a function. Look at it, it's kind of a, it's not a quadratic function, okay, but it is a curvy function, all right? And today we're going to be talking about turning points most specifically, all right? Now, turning points are also known as maximums and minimums. Mims, okay? So a turning point would be about this point here and about this point here. You can see it's a turning point because we're going from a positive gradient to a negative gradient, okay? And here we're coming from a negative gradient up to a positive gradient. So this is a max or a maximum. And in the case of this particular function here, this is what we call a local max. And this is a minimum or a local minimum. You don't know that. There could be another one further up. We don't know. Okay, but this is our min and this is our max. Now, what can we tell about the gradient at these points? Well, the gradient, what's the gradient of a straight horizontal line? Well, the gradient is 0. So let's go back to one of our traditional colors here. So at a turning point, the gradient equals 0. Therefore, the derivative, or dy dx, is equal to 0. Okay? So you would expect that if I was to take the derivative at this point here, that it would be a positive answer, okay, because the gradient of the tangent at that point is positive. If I was to take the derivative at this point here, you would expect that I have a negative number, okay? That would be because the tangent at that point is going to have a negative gradient. And right at the turning point, right at the point where it goes from a positive gradient to a negative gradient, we're going to have a gradient that equals 0, okay? And the same thing here. At this point here, we're going to have a gradient that's going to be negative. At this point here, we're going to have a gradient of the tangent, which is going to be positive. And here, right at the point where it switches from a negative gradient to a positive gradient, we're going to have our tangent's going to be a horizontal line. We're going to have a gradient of 0. Okay, so at turning points, have a gradient, or the dy dx is equal to 0. All right. Now, here we can see when we have a negative going on to a zero gradient to a positive gradient, we have a minimum. And here when we have a positive gradient going to zero gradient going to a negative gradient, we have a maximum. All right, so what does that look like? And this could be a question that you may be asked on the exam. Okay, so what do? Let's go to red flavor here. Find the turning points of this function and state whether each is a maximum or a minimum point. Okay, so when it says here find the turning points, it looks like we're going to have more than one. If I had a parabola, for example, if I had, y is equal to 2x squared plus 3, for example, I'm only going to have one turning point. And that one turning point in this particular case will be a minimum. All right. But here in this function, and if you notice, this function has an x to the power of 3. All right. The greater the number of the exponent of our variable, the greater the number of curves, okay, and maximums and minimums. So if we notice here, when we have a parabola or something to the power of 2, we have one, we have a maximum or we have a minimum, okay. But here, x to the power of 3, that means we're going to have two different ones. All right, so what do? Find the turning points. Well, what do we know? We know that there is a turning point when the derivative of the function or the gradient function is equal to 0. So the first thing I need to do is I need to find the derivative of this function. So I'm going to say, okay, so dy dx of this function is going to be equal to what? What's the derivative of x to the power of 3? Applying the power rule will be 3x to the power of 2. What's the derivative of 12x? Well, it's going to be minus 12. What's the derivative of 4? 0. So this is our derivative function here. This is our gradient. What was I saying? This is our gradient function. So what I know is that at the turning points, this is actually equal to 0. Okay. So I know that 3x squared minus 12 is equal to 0. So where is it equal to 0? Where are these turning points? Well, I just have to solve for x now, because if I solve for x, it's going to tell me where my gradient is equal to 0. It's going to give me an x coordinate, and then I can figure that out. Okay, so let's do that. We've set our derivative to 0, all right, and now I just need to solve here. So I can just go, okay, well then I'll have 3x squared is equal to 12, all right, and then I'll divide both sides by 3, so x squared is equal to 4, and then x is going to be equal to the square root, because the x is the square root of x squared, so I take the square of both sides. It's going to equal to plus or minus 2, okay. So when x is equal to plus or minus 2, the gradient is equal to 0, meaning that they're our turning points. But we are not done, because we haven't just been asked to find the turning points. So we've found the turning points. Turning points are found. Done. The turning points are when x is equal to positive or negative 2. Actually, that's not completely complete yet. We know that that's the x part. What's the y coordinate? But we want to know whether or not they are a maximum or a minimum point. Okay. So let's figure out exactly where those turning points are. Let's find an actual coordinate pair for those two so we can see where they are. So let's go with black here, black flavor. So when we've got two x values, so how about when x is equal to positive 2, all right, what's our y coordinate going to be? So all I need to do is substitute this into our initial function. Okay, I can go, okay, so what's my, this is going to tell me what my y coordinate is when x is equal to 2. So I'm going to say, well, what's y going to equal? Y is going to equal 2 cubed minus 12 times 2 plus 4, which is equal to 2 times 2 times 2, which is 8, minus 12 times 2, minus 24, plus 4, which is equal to 8 minus 24 plus 4 will give us minus 20. So the first turning point is going to be positive 2 minus 20. Okay, that's one turning point. Now let's look at the next turning point. And we'll use a different flavour here to separate the two. Let's use red flavour. So what about when x is equal to minus 2? All right, we're going to do the same thing. We're going to substitute that into equation. So we'll say, well, what's y going to be equal to? Well, y is going to be equal to minus 2 cubed minus 12.
I'm pretty sure he muted us all.
Minus 2 plus 4, which will be equal to minus 2 to the power of 3. Well, 2 to the power of 3 is 8. And when we have a odd exponent and we're multiplying that out with a negative number, it's always going to be negative, so we'll have negative 8. Minus 12 minus 12 times minus 2, that's going to be positive 24 plus 4, which is going to equal to 12. Is that right?
Bro, he's recording, you know that, right?
Well, this is incorrect. Let me have a look at that. That's minus 12. Minus 12 here, because 8 minus 24 plus 24, so it's going to be minus 20, that's going to be minus 12. And this guy here is going to be 20, because minus 8 plus 24 is going to be 20. I hope you picked that up while I was doing that. So that's going to be minus 2 and 20. So they're our 2 points. And now we've got to decide whether which one's max and which one's a minimum, or if they're both a max or if they're both a minimum. Is it max or min? This one or this one? Now, a good way to start off of doing this is to actually draw the positions on a quick graph. Okay, so let me just draw a quick graph. Here we'll go, okay, about there, all right, and we'll say, we'll give that positive 20, all right, and this will be minus 12, all right, and we'll say that this is positive 2, and this is negative 2, all right, so we've got two positions here. I've got 2 minus 12, so positive 2 minus 12. So we've got, this is one of our positions here. And then we've got minus 2 here and positive 20 here. Okay. Now you can already see that it's looking like this one here is your maximum and this one here is your minimum. It's kind of obvious now that I've drawn it, isn't it? But there's another way that we can check. Okay. Now what we can check is what's going on either side of each of these points, okay? Because this is going to be a stationary point. All right, this means that the derivative at that particular point is 0, all right, or a turning point, okay? Now, if this was a minimum, we would expect this here to have a negative gradient and this here to have a positive gradient. And if this was a maximum, we'd expect this side here to have a positive gradient and this side here to have a negative gradient. Okay, so let's double check that. How do we double check that? Well, let's just substitute our x values into our derivative, and if we get a negative number here, we know that's got a negative gradient. And if we get a positive number here, we know it's a positive gradient there. So let's go with a different color. Got red there. Let's go for blue. Okay, now just a reminder, our derivative is 3x squared minus 12. So 3x squared minus 12. All right, that's our derivative. I figured that out before. So I just need to substitute in my x value. So here, let's figure out what the gradient is at 0. So if I substitute 0 into this, I'll have 3 lots of 0 squared, all right, minus 12, which is equal to minus 12. There we have it. We have a negative gradient. So we know at 0, there's a negative gradient. Okay. What about on the other side of this point here? So this here is our first point up here. What about on the other side? How about if I substitute 3 in there? So if I substitute 3 into my derivative function, 3 squared minus 12. Okay, so 3 squared is 9. 9 times 3 is 27. 27 minus 12. That's 27 minus 12. Is we're going to have 15. That's a positive. So here we have a negative, and here we have a positive. Now, since this is a positive, okay, since this is a positive, we know that at 3, when x is equal to 3, because that's what we put in there, we're going to have a positive gradient. So we can see that this is definitely, this point here is definitely a min. It's a minimum. So we have a min. Okay, and then finally, let's look at our next one here. So that's this guy over here. Let's just substitute. Well, we know that on the right side of this here, we have a negative gradient. We can test this side here just to make sure that we still have a, that we have a positive gradient. So I can just put in negative 3. So if I put negative 3 into my function, so 3 lots of negative 3 squared minus 12. Negative 3 squared is going to be 9. 9 is 27. So we have 27 here minus 12. And that's going to be equal to 15. Positive number, which is positive. So we know that the gradient at this point here is positive. This side here we know is negative, so this is a max. So we have a max. All right. So a lot to go through there, and hence why I'm recording it, so you can go back and look at that. So what I'll get you guys to do is I'll go just D, and I'll grab this B. Okay, now we're doing exercise 22C. Now what page is that on? That is on page 370. 370 to 371. 1. Make sure you check your answers and make sure you mark that on the checklist. Now, just going over again one more time, year 11. So make sure that you, if you're here now and that you participated in the Kahoot, you put down done here, okay? Because, you know, and I'll be able to double check that because your name should be on the Kahoot list. And then once you've completed the exercise here, put done there. And once you've checked your answers, put done there. And if you struggle, just send me a question. Okay, that's what I'm here for. All right, let me have a look. Okay, so I'm going to stop sharing my screen now. Okay, all the best with that. That's a little bit to get through. Rewatch the video if need be. Have a crack at those practice questions to see how you go and let me know if you have any problems. All right. You guys keep being awesome and I will chat to you guys on Monday. When we have a lesson on Monday, period 3 at 10 o'clock. I'll see you guys at 10 o'clock. Rock and roll.